You ever stop and think about the hidden power locked away in just a simple change in temperature? I mean, we're talking about a force of nature that works silently, it's predictable, but it's got enough raw strength to bend solid steel like it's nothing. Today, we're diving into the incredible physics of thermal expansion.
It just doesn't sound right, does it? How can something as normal as a hot day generate enough force to completely buckle industrial-grade steel? Well, that's the big question we're going to answer right now. So, to really get our heads around this immense power, we have to start with the principle behind it. And it all kicks off with a really simple, fundamental law of physics.
At the very heart of this is a pretty simple formula. Now, it might look a little intimidating, but it's just a precise way of saying something we all kind of know. When things get hot, they get bigger. That delta L is just the change in length, and it's based on the material itself, how long it was to begin with, and of course, how much the temperature changes. It's just a basic rule of how the universe works.
And you know, for the most part, this is totally harmless. Engineers know all about it, they plan for it, it's just a predictable part of our world. A pipe gets hot, it grows a tiny bit. No big deal, right?
And this is where everything changes. What happens when you take that natural tendency to grow and you put a brick wall in its way? What if that pipe is bolted down at both ends with absolutely nowhere to go? This is the exact moment a simple law of physics becomes a serious cautionary tale.
So, when that unstoppable urge to expand meets an immovable object, well, something's got to give. The energy from that growth, it doesn't just disappear into thin air. Oh no, it transforms into something else, something much, much more powerful.
Okay, so check this out. Here are the two realities. On the left, you've got a pipe that's free to expand. It gets a little longer, no stress, everybody's happy. But on the right, that exact same pipe is locked down tight. Since it can't physically get longer, all that energy turns inward, creating an absolutely massive internal force.
This monster force has a name. It's called thermal stress, and here's its formula. It looks pretty similar to the other one, but you see that big E in there? That's the game changer. It stands for Young's modulus, which is basically just a number that tells you how stiff a material is. And for something like steel, that number is huge, which means the resulting stress is, you guessed it, absolutely off the charts. So, what does this massive force actually do in the real world? This isn't just some problem on a whiteboard. This has very real, and let me tell you, very dangerous consequences.
I want you to just let that sink in for a second. We are not talking about a gentle nudge. This is a force that can twist enormous steel pipes into scrap metal, or literally tear heavy industrial machines right off the concrete floor they're bolted to. When you get down to it, ignoring this force leads to total disaster. We're talking catastrophic system failures, completely destroyed equipment, and some incredibly dangerous situations for anyone unlucky enough to be nearby. This is why understanding this invisible force is, frankly, a life-or-death matter in engineering.
All right, let's actually visualize how dramatically things spiral out of control when you take away that freedom of movement. The difference isn't small, it's staggering.
I mean, just look at the difference here. The bar on the left, that's the stress when the pipe can grow freely. It's basically zero. Now, look at the bar on the right. All we did was add one thing, restriction, and the stress level just explodes. It's not a little bit more, it's an exponential leap, straight into the danger zone.
Okay, so we've established the danger. It's a huge, destructive force. But here's the good news. For every powerful force in nature, there's usually a really clever engineering solution designed to tame it.
Here it is, the problem and the solution, side by side. A long, straight, rigid pipe is just a disaster waiting to happen. But look at the solution. It's just a simple U-shaped bend called an expansion loop. It is an absolutely brilliant and elegant fix. See, instead of trying to fight this unstoppable force, engineers just give it a safe place to go. This loop acts like a giant spring, flexing and absorbing that change in length without any drama. It doesn't stop the expansion, it just gives it a purpose-built detour. It turns a destructive force into a harmless, predictable movement.
So it really all boils down to this simple three-step logic. First, you have to accept that things are going to grow. Step 2, you find all the spots where that growth is going to be blocked. And third, you design in some flexibility, like our expansion loop, to give that growth a safe way out. It's all about working with the laws of physics, not against them.
And that leaves us with one last thought. We just saw how a simple law of heat can become a catastrophic force, and how a clever little design choice can tame it completely. It really makes you wonder, doesn't it? what other powerful, invisible forces have been quietly engineered into the bridges we cross, the buildings we're in, and the systems we rely on every single day.